now,
Oh,
see, mute ಮಾಡ್ಕೊಳ್ಳಿ.
ಪಚ್ಚದೇಮ ದೇಮ
See now, in module 3, we are going to discuss about the process of runoff. So, among the three different phases of hydrologic cycle, that is evaporation, evapotranspiration, and precipitation, and the third one is the runoff or overland flow, or it is also called as surface runoff. So, this part is very important for engineers in order to design the various hydraulic structures, whether it may be a reservoir or it may be a canal or it may be a powerhouse or it can be any hydrologic project or discharging the excess water through. Now this figure clearly shows how the process of runoff takes place. Now this is the ground surface. You have the depressions on the ground surface. And here, whenever a precipitation takes place, so the initial losses will be the interception losses. The next will be the water infiltrates into the ground surface and builds up the groundwater table. And once the soil moisture becomes saturated, the excess water moves down and builds up the groundwater. Now, in this figure, you can see here there are two types of streams. That is, one is the influence stream. The other one is the effluent stream. So the difference between influent stream and the effluent stream, you can see the water surface in both the streams. So in this case, the stream feeds the groundwater. You can see here, the stream feeds the groundwater. So hence those streams which feeds the groundwater or builds up the groundwater. So here you have the banks of the stream. So if it is pervious, so whatever the water that is in the stream that tries to enter through these pores and builds up the groundwater. So such streams are called as influent streams. So the other one is the effluent stream. Here, once the groundwater table increases and it becomes saturated, and some portion of the groundwater joins the stream. So such streams are known as the effluent stream. So this figure clearly shows you how the overland flow occurs. So whenever a precipitation takes place, after all the initial losses, the remaining water flows over the land, so which is known as the overland flow or the surface runoff. Now, let us define what is effective rainfall. So the rainfall that becomes runoff, whatever the portion of rainfall that becomes runoff is called as effective rainfall. Effective rainfall is nothing but the precipitation, whatever the precipitation that has taken in a particular area minus the initial losses or the initial abstractions. So that is nothing but the effective rainfall. So it's also called as rainfall excess. So runoff is also called as whatever the rainfall excess. So this rainfall excess can also be calculated by the hydrograph. You can calculate the total precipitation and whatever the losses that is below that Harton's infiltration curve, the remaining part is nothing but the P net or the excess rainfall. Now effective rainfall is nothing but rainfall excess, or it is also called as runoff. So runoff occurs only when the rate of precipitation exceeds the rate at which water may infiltrate into the soil. So that means the intensity of the rainfall. So runoff only occurs when the intensity of the rainfall is greater than the rate of infiltration in that particular area, in that particular soil condition. Next, so let us discuss how runoff actually occurs or how it happens. How does runoff occur? When rainfall exceeds the infiltration rate at the surface, excess water begins to accumulate as surface storage in small depressions. As depression storage begins to fill, the overland flow or sheet flow may begin to occur, and this flow is called as the surface runoff. So once the infiltration, the major loss is the infiltration loss, and initially there will be interception loss, and the remaining water flows over the land surface, and if there is any depressions on the land surface are called as small depressions. So these depressions are filled with the water. The remaining water, after filling all these depressions, flows over the land as a thin sheet of water, so which is called as surface runoff. Now portion not absorbed by the deep strata, it is also called as runoff. So runoff mainly depends on the amount of rainfall that has taken place or the intensity of rainfall and the soil characteristics or the soil type and the evaporation capacity and the type of land use. So whether it is a barren land or it is a cultivated land or it is a forest land. So these are some of the factors on which the runoff mainly depends. Now the amount of rainfall, the runoff is in direct proportion to the rainfall. As the rainfall intensity or rainfall duration increases, the chance of increase in runoff will also increases. It is obvious. Next, soil type. Infiltration depends mainly on the type of soil. If you have a porous soil, so the rate of infiltration will be more. And if you have a clay soil, clay surface soil, the infiltration will be very less. So next also the evaporation capacity. If the evaporation capacity is more, surface runoff will be reduced. So this evaporation mainly depends on the temperature or climatic condition of that particular area. Now these are some of the components of runoff. Overland flow or surface runoff, the water that travels over the ground surface to join a stream. The amount of surface flow may be small since it may only occur over a permeable soil surface when the rainfall rate exceeds the local infiltration capacity. That means in order to have sufficient runoff or the surface runoff or the overland flow, the rainfall intensity should be greater than the rate of infiltration or the infiltration capacity. Next, interflow or subsurface storm flow. The precipitation that infiltrates the soil surface and moves laterally through the upper soil layers until it enters a small stream. Sometimes what happens, some water get infiltrated into the soil surface and it builds up the soil moisture. It builds up the soil moisture. So then what will happen? Some portion of the water moves laterally soon after below the ground surface. So this portion of water which moves laterally and enters the stream is called as the interflow or subsurface storm flow. Next, groundwater flow or base flow. So once the groundwater is saturated, then the groundwater contributes to the stream flow, So among all this, the overland flow or the surface runoff reaches the stream very fast. And this interflow or subsurface flow, it takes some time. It may be 1 day or 1 week, so it will join the stream. So this groundwater movement, groundwater contribution to the stream flow, it takes few weeks or months, because once the groundwater is saturated, then the excess water moves and it joins the stream. So the portion of precipitation that percolates downwards until it reaches the water table, this water accretion or buildup of groundwater may eventually discharge into the stream if the water table intersects the stream channel of the basin. That means if the groundwater elevation is higher than the water surface elevation in the stream, obviously there will be a contribution of groundwater flow into the stream flow. However, its contribution to the stream flow cannot fluctuate rapidly because of its slow flow velocity, because it reaches the stream after some weeks or some months. Now these are some of the figures which shows how the overland flow takes place after meeting all the infiltration losses. Now you can see here a thin sheet of water flows over the land surface. And now here this figures clearly explain the catchment area, or it is also called as a watershed area. So the area which receives the rainfall or precipitation is called as the catchment area. And you can see here you have the mountains on two sides, and here you have a natural stream. Here. Now whatever the precipitation takes place. So after meeting all the infiltration and other losses, you can see the overland flow or the surface runoff joins the stream. And you can also see here the groundwater recharge also takes place. And if the groundwater mound is higher than the surface level of the water in the stream, obviously there will be contribution of groundwater into the stream flow. Now let us define what is a catchment area, or it can also be called as a drainage area, or it can also be called as a drainage basin, or it can also be called as a watershed. So you can call the catchment area as one is catchment area, or it may be a drainage area, or it may be a drainage basin, or it can also be called as a watershed or a catchment area. Now here you can see here, this is the typical figure of the catchment. So here you have the precipitation takes place, and here you have the forest vegetation, and here you can see you have a main stream, main natural stream, and to this main natural stream you have the small tributaries. So these are the tributaries which finally joins the main natural stream. So now whatever the precipitation that takes place, you can see here some portion of the water is intercepted by the forest vegetation and it will be returned back to the atmosphere. Then remaining part infiltrates, and you can see here once the infiltration that is the moisture level builds up in the soil, you can see some portion of the water moves laterally and joins the mainstream. So this component is known as interflow or subsurface flow. So now you can see here, once the groundwater also builds up, once the saturation, that is the soil moisture is at its maximum level, then the excess water moves down and builds up the groundwater table. So once the groundwater mound is elevated, then it will also contribute to the stream flow. So among all these, the surface runoff joins the stream very fast, and the subsurface or interflow, it takes some time to reach the stream flow. So the groundwater being the contribution being delayed, it may take some weeks or months. So now this is the typical, this is the 3D model of the catchment area, how exactly it looks like. Now you can see here, this is the figure of the catchment area. Now you can see here you have a natural stream, and these are the tributaries to the natural stream. So these tributaries will also contribute to the natural stream. Now this is the shape of the catchment area. This is the shape of the catchment area, and this line is called as the boundary of the catchment area. Or it can also be called as a watershed divide, a line which separates two watershed. Now you can have one more adjacent watershed on this side or maybe on this side, and the boundary which defines the particular catchment under study. So this line or the outside line is also called as the catchment boundary, or it's also called as the drainage divide or watershed divide or catchment divide. Now here, since it has the flow is natural and gravitational flow, you have a gravitational flow, you can see here gravitational flow. Now here, whatever the water, after meeting all the losses, it comes out of the catchment area. At a particular point or a particular location or a particular site. And this point where you are going to measure the outflow from the catchment area. So this point is called as the concentration point. This point is called as the concentration point, where you are going to measure the entire discharge from the catchment area at this point. So now already you know how to calculate the discharge in case of an open channel flow. So in the fluid mechanics laboratory, you know what is the procedure, how to calculate the discharge in a open channel flow. So it is almost similar here, since you have a gravity flow, because from the higher elevation to lower elevation. So where you are going to measure the entire discharge from the catchment area is called as the concentration point. And the time taken by the rainwater, which has fallen on the periphery of the catchment area to reach this point, the time taken by the raindrop to reach from this boundary to this concentration point is called as the time of concentration. If the intensity of the rainfall is more, then the concentration time is less. And if the intensity of the rainfall is less, then obviously the concentration time, that is the time required by the water which has fallen on the periphery of the catchment area to reach this point. Now here, this is the topographic map showing the location of the drainage divide or the watershed divide. Now you can see here, you have a particular catchment under question. So this is the boundary line of the catchment area, or it's also called as the drainage divide. Now here, you have two sites, that is, one is site A and the other one is site B. So this dotted line refers the boundary line for this site B, and this area, the remaining area refers to site A. So here also you can see you have a natural stream, and these are the tributaries, and here you can measure the catchment or the discharge from this catchment at this point, that is the concentration point, and you can also measure the outflow from this catchment at point E. Now, in a given catchment, you have a main stream, you have a branch stream, and you have small tributaries. So based on experiments or based on investigation, so the streams have been ordered, this ordering of streams, they are numbered here. You can see here 1, 1, 2, 2, 3, 3, 4, like that. Now, these are some of the typical stream patterns. It may be dendritic, or it may be trellis, or it may be radial, or it may be subdendritic, or it may be parallel, subparallel, and annular, rectangular, and pinnate. So these are some of the stream patterns that are commonly observed in some of the catchment area. It depends on the topography of that particular area, Now here, so ordering of the stream. Now here this figure typically explains the drainage basin characteristics. What are the characteristics of a catchment area? Now here you have a particular catchment area. You have considered this as a particular catchment area, and this is the main stream you have, and you have these tributaries. These are small tributaries which contribute the flow to the mainstream, and this the extreme point is called as basin boundary, or it's also called as basin divide. So for hydrologic analysis, we are going to consider this area equivalent to a circular area. You can see here equivalent circular area is considered approximately. So the circular area will be equal to the area of catchment. So for hydrologic analysis, we need to consider this irregular shape area as a circular area. So the circular area almost equal to the area of this catchment area. Now this is the remote fringe of the catchment. Now we shall take the axial length of the catchment area and the axial width of the catchment area. So that it will give you the area. So that is nothing but equal to the area of the circle, pi r square. So what we have done is we have considered a circular area which is almost equivalent to the area of the catchment under investigation or under question. So the area of the catchment is nothing but length into breadth, axial length into axial breadth. So since we can consider a circular area, the area of the circle is pi r square. So for hydrologic analysis, so the area can be converted into a area which is almost equal to the original area. So this is nothing but the drainage basin characteristics. So you can see here, this is the axial length, axial width, this is the drainage boundary, and this is the remotest point, that is the farthest point, and this is the discharge site where the outflow is measured. Outflow is measured in cubits, and now, so since there is a network issue, I request all of you to mark your attendance in the chat box now. Now you can mark your attendance. Hello, am I audible? So now this is the figure which gives you information about the drainage basin characteristics. Now again, this figure you can see the catchment area. The land is not leveled very well. You have these undulations because these undulations are required. Otherwise, if it is a flat land, you cannot expect more runoff. The topography consists of plain land and mountains. You can see here you have the hillocks, peaks, and valleys. And rainwater from mountain tops or high land flows on slopes, obviously. And this flowing water accumulates on the plain area known as the catchment also. Here this water accumulates. The entire thing is a catchment area. And this flowing water accumulates in the plain area known as the catchment, also called as drainage area or drainage basin. It's also called as watershed. You can call it by any name. Next, now let us discuss how to select a particular area or a catchment area for hydrologic analysis. Now, catchment area consists of a river basin or a source stream. And in any case, if you want to carry out any investigation in an area, you should have a natural stream flowing through the catchment area. Now, it can span huge area. The size should not be small. It should not be taken less than 250 kilometers square, or it should not be too big also. If you take big catchment area, then in such a case, you have to divide the bigger one into small part, and each part has to be analyzed separately. So small catchment area is not beneficial for storage. So if it is less than 250 kilometers square, it should be selected such that minimum 5 villages are benefited, because the ultimate purpose of this selecting a catchment area is we need to know the amount of water that comes out of the catchment, so that that water can be stored in small ponds or reservoir, and it can be supplied for the various purposes. That is the main idea of selecting a particular catchment. Now, here this figure shows the type of structures: small check dams, lake construction, cemented bunding, small dams, contour making. So these are again it will be discussed in the irrigation engineering in module 4 and module 5. Now, classification of streams. So the classification of streams in a given catchment area, there are two types of classification. One is the influent stream and the effluent stream. So influent stream is nothing but the influent stream feeds the groundwater, whereas the effluent stream is vice versa. The groundwater feeds the stream. Next, you have the second classification, that is intermittent streams and perennial streams. So in the southern parts of India, we have the intermittent stream, where you have the flow only during monsoon period, whereas in the northern India, you have the perennial stream, so where you have sufficient flow throughout the year. Also in the summer months, you have the snow melt runoff. So those streams are called perennial streams. Now these are the figures which clearly shows how the streams can be classified into influent stream. Now you can see here, this is the high water water level in the stream, and this is the low water level. So because you can see here, there is the groundwater recharge, and this is the groundwater mound, and these are nothing but the seepage lines. So if you have a pervious banks, the stream will feed the groundwater. So this is the other way, where the groundwater mound is greater than the lower water level in the stream. So obviously, there will be contribution of groundwater to the stream flow. So these two figures clearly explains what is an influent stream and an effluent stream. Now in the next class, we shall discuss now, since the time is running out. So if anybody has not marked your attendance, please mark it. So tomorrow also at 9:20 I will engage the class. I think on Saturday you have the internals, correct? From Saturday, the first internals will start, online internals, correct? Have you received the timetable? Anyone? Anyone can?
Yes, sir.
Timetable have you received? So the portions for the first test, it will be module 1 and module 2. I think module 1 study material have been shared to you. I have told Chaya madam to share the module 2 notes also. So the syllabus for the first internals is module 1 and module 2. So you'll have 4 questions, 1 or 2, 3 or 4. So anyway, tomorrow you'll engage the class, and tomorrow also I'll give you some assignments question, one assignment, first assignment questions. So you have to submit that assignment in Google Classroom. I'll share the link on or before the first test. So before the conduction of the first test, you have to submit the assignment. Anyway, tomorrow I'll share the assignment questions to all of you. So I'll be ending the session. So thank you so much. So have a nice day. Stay safe. Thank you.